Hi, I'm Terence Tan and you're watching Theta. We will be starting the series with algebra, which we will be splitting it into 10 different videos. In this video, we will be first looking at the simultaneous equation, where we will be exploring what variables are and how to go about solving for both the linear and non-linear simultaneous equation. So if you're ready, let's begin. So, by definition, simultaneous equations are just a set of equations containing multiple variables. But what exactly are variables? Let us illustrate with the man in the blue box. He can be moving forward or backwards, but those are the only two movements that he can be taking. As such, this is denoted with a single variable x, for he is moving in a single one dimension. Now, let's say that there is a flight of stairs. Not only can he be moving forward and backwards, he can also be climbing up and out. This is two-dimensional and we denote them with the letter x and y, which are two different variables. We live in a three-dimensional universe. Besides going forward and backwards, we can also be moving left and right as well as jumping up and down. In this scenario, we denote them with three letters to show our different movement. Let us focus on the two-dimensional plane. We denote the path with the letter x and y, where the position is known as a solution. This is just a set of values that makes the simultaneous equation true. We often represent it in the coordinate system, bracket x, comma y, close bracket, and this is called the intersection point of the graph. Graphs are simply lines or curves drawn on a piece of paper. We will now be focusing on solving for linear simultaneous equations. These are just equations to represent straight lines. Let us illustrate what the solutions are. Take, for instance, that the man can only be moving forward or backwards. Likewise, the CCTV can only record a single path. At some point in time, the man will be caught by the CCTV, and the position that the man is caught is the solutions. There is usually only one solution to a pair of simultaneous linear equations. However, it is possible that there is no solutions at all, and this is because the lines are parallel to each other. On the other hand, if the lines are exactly the same, then there will be infinitely many solutions. There are four methods which we can use to solve for a pair of linear equations. Firstly, we can solve them graphically, but this is not advisable. We can also use the matrix method, but this is not in the syllabus and thus should not be employed. Rather, we will be solving them using either the elimination method or the substitution method. Let us first focus on the elimination method. This can be done by making the coefficient of one of the variables the same, before adding or subtracting both the equation to form a single equation with only one variable. Let us use an example to demonstrate it. Suppose you want to find the value of x and y in the given equation. 2x plus 3y equals to 15 and negative 3y plus 4x equals to 3. Notice that in both equations it contains 3y. We can simply add both the equations together to eliminate it. We combine both the left hand side together and equate it to the sum of the right hand side. This will give us the following. We then divide by 6 to give us x is equals to 3. We then use this value of x to substitute it into equation 1, and this will leave us with the equation of y. As such, we will be given 3y equals to 9, which we can simplify it to be y equals to 3. Therefore, when x is equals to 3, y is equals to 3. The other method that is used is known as substitution, which is more commonly used than the previous method. This method will require you to make a variable the subject of the chosen equation before substituting it into the outer equation. It may sound complicated, but it really is not. Imagine you want to buy some apples, which are selling at $2 each. If you choose to get 4 apples, then you will have to be paying $8. We are actually using the substitution method here, where we replace each apple for the number of apples that you want to get. This is the same idea when we apply the substitution method. Let us try to solve for the given equation. If we look at equation number 2, we see that there is a variable y that has the coefficient 1. We can simply bring 4x over to the right hand side and call it equation number 3. Then, we just need to change the y in equation number 1 with the new equation. By simplifying the equation, we will get x is equals to 5. And using this value, we will also obtain the value y is equals to 4. Therefore, when x is equals to 5, y is equals to 4. Not all equations are linear. This occurs when a variable is multiplied to another variable, such as x squared or xy. Let us assume that an eagle wants to catch its prey, and that a rat is running in a straight line. To catch up to it, the eagle will have to sweep down. While the eagle might not have moved in a straight line, it still manages to catch its foot. If we are given the equation of both the eagle's and the rat's path, we can calculate the coordinate at which they meet. There are two methods which can be used to solve for non-linear simultaneous equation. Like before, the graphical method is highly not recommended. Instead, we will be using the substitution method. There is a mnemonic that we can use to go about this process, and it is let's stop eating sugary food, which requires us to first find the linear equation, then substitute it into the other equation before expanding, simplifying, and factorizing for the solutions. Let us take a look at an example to see how we can apply it. Say we are given the following two equations. By choosing the linear equation, we can express x in terms of y. We might want to express y in terms of x instead, and that is not an issue. We then substitute it into the second equation and expand the left-hand side. We then bring the expression on the right to the left to get y squared minus 6y minus 7 equals to 0, and this is the simplified form. We can proceed to factorize the equation and get y equals to 7 or y equals to minus 1. By substituting this value into the equation 3, we get x equals to 18 or x equals to negative 6 respectively. Let us look at another question. This time, we are not given any equation, however, we can form them. As we need to find two positive numbers, we can use the unknown x and y. From the first statement, we can add the square of the number to get x squared plus y squared equals to 37. We then go about forming a second equation using the second statement. Assuming that x to be bigger than y, we can take x minus y to be equals to 5. As this is a linear equation, we can make x the subject and substitute it into the non-linear equation. We then proceed to expand and make the right-hand side to be 0. This will give us 2y squared plus 10y minus 12 to be equals to 0, which we can then simplify by dividing by 2. Then, by factorizing, we are left with y to be equals to negative 6 or y to be equals to 1. We reject the first answer as it is not positive, and using y to be equals to 1, we see that x is equals to 6, and those are our two positive values. Let us summarize what we have studied. We define what simultaneous equations are and that the solution is often written in the coordinate system form. We also explored two different types of simultaneous equations. For the linear simultaneous equation, we note that there is usually only one solution. However, in the event that there are more than one solutions, then the lines are said to be equal. On the other hand, if there is no solutions at all, then the lines are said to be parallel. We also noted that we can use the elimination method or the substitution method to help us find for the solutions. Next, we learned that the substitution method can be used to help us solve for simultaneous non-linear equation. We can employ the mnemonics let's stop eating sugary food to help us find for the answers. Lastly, we may use the graphical method to help us find for the solutions, but this method is not recommended.